Yeah. So we'll start the class, friends. That is second class on the third sprint. So before I start this class, so we'll quickly go through in the last class on the first day one, what are all the concepts that we have discussed. So, right. So first we started with the two-pointer technique. I told two-pointer techniques of two types. So type one, both pointers move in the same direction, whereas in opposite direction. Whereas in type two, both pointers basically moves in a same direction. Right. So opposite direction, we have seen lot of problems. So first opposite direction. So here we seen one problem called find a pair whose sum is equal to k. Very standard question. You can expect in the interviews also these kind of questions. So here the idea will be, first we have seen the brute force solution where its time complexity will be order of n square. Then we have seen the optimized version of that. So to apply two-pointer technique on this the given array, first of all, you need to sort the array. Without sorting, you cannot apply. So after sorting, so you point one pointer L at the beginning and R at the end. So take L plus R and you have to compare with given K. Depends upon condition. If sum and K both are equal, we are happy. If sum is less than K, you should increment L. Otherwise, you have to decrement the R. So we have even seen the code also based on this. And it's turned out that time complexity will be n log n because it's a time complexity. Because sorting its take, right? Okay. Next. Then we have seen the triplet. So which is, I gave the idea also, triplet. First, again, you have to sort the array. You have to take one loop outside and inside you have to apply the two-pointer technique. Same, I starting from 0 to n minus 3 and inside you have to apply the two-pointer techniques. Next. So one more question we have seen, that is separate zeros and ones. So keep all the zeros at the beginning and keep all ones at the end. Okay. So we have even seen the approaches also here. Again, two-pointer technique only. This is the approach. And then we have seen the reverse the array in place. In place means space complexity will be order of 1. So you should not supposed to use any extra array to reverse this array. So two-pointer technique plus swap. So we have taken one pointer beginning and ending. So two-pointer and then swap. Same idea you can apply even for the checking palindrome or not. Okay. So next, two-pointer which are moves in a same direction. So friends, two pointers which moves in the same direction, we have discussed one question, that is merge two sorted arrays. If two sorted arrays will be given to you, so you need to bring up the final sorted array, right? So for that also, so we taken 3 pointers, actually one pointer for this first array, second pointer for be here, and the third pointer will be here, right? So compare this one and this one, among whichever is small, that one you have to keep it here. So from which element you copy it here, respective variable you have to increment, as well as you have to increment the variable which is pointing to final array also, right? In fact, partially this code we have seen. So here one edge case is coming. What if some of the elements are left either in the first array or the second array? So you need to copy those elements. You need to copy those elements. Okay. So till here we have discussed, friends. So now I will discuss one more question, which is an example of two pointers which moves in a same direction. Same direction. Okay. Just a minute. Why people are typing in the comments? Tell me. Why Anwar, Archit, Arpit, why you are typing? Do I need to teach my class or do I need to see the chart? Chaitanya, please note these students' names. Vishal Sharma, Satya Sai, please note the students of their names. Do I focus on the class or do I focus on your chart? Please note down all those names. Whoever disturbing the class in between, kindly note. Navid, you also please note down. Or whoever IA, please everyone note down these fellows' names. I am only one person present here. Do I need to teach here or do I need to chart? Remember, if anybody disturbing the class in between, kindly note down their names. Next class, you won't be able to come. I'll strictly make sure that. Don't you think you have hours of time? So if I ask something, you please respond in the class. That's it. Other than anything, if you are asking some other context questions, it is not a good time to ask in the class. In the class, focus on the class only. Cool. So next question. So another question, friends, that is remove duplicates, from the sorted array, right? So for example, here, if the input will be, array, which is sorted array, friends. Okay. So all the elements that are present in there are sorted, and the number of elements that are present in this array are 9. Now, what is the expected output if this is the input? So all the elements which are, you have to remove duplicates and you have to print it. So here 1 is coming for 3 times, but you have to print only once. Afterwards, 2 is coming 2 times, but you have to print only 1 time, then 3, and then 4. If this is the input, after removing the duplicates, your output should look like 1, 2, 3, 4. Similarly, if the input is this array, so number of elements are also here 9. So the output will be 1, and then 2, and then 3, 4, 5. So you have to print only the distinct elements. Duplicate elements should not supposed to print it, right? So this is the problem statement. So what are the different approaches to solve this question? Simple. One simple approach is you can use key value pair. So let me write it here. First, approach number 1. So approach number 1, friends, you can simply use the objects. So just a minute. Sorry. Yeah. So where are we at? Yes. So we need to print only the distinct elements, friends. So first approach is we can use the concept of objects. So in objects, every element you keep there and see how many times it is getting repeated. So in that, you can print only the keys. So you can simply print the case. So you can easily get it. Now with this, can you help me? What is the time complexity of this approach? If I go and use worst case. So worst case, you might need to traverse the given array completely once. Therefore, the time complexity will be order of n. Okay. Worst case, what about the space complexity? Which is also order of n. Why worst case space will be order of n? Because there might be a case all the array elements are distinct. When all array elements are unique, then you might create an object whose size will be as good as the given array size. Therefore, worst case, your space complexity is going to become order of n. If all the elements are same, then only one entry will be present inside that object. Therefore, only one space will be required. But we have to always think about worst case, right? So if all the elements are distinct, then how many number of elements are there in the given array? Those many entries will come in the object with value as 1, 1, 1, 1, and so on. But can you do it in order of n time and order of one space? So there, the concept of 2 pointers will be applicable, friends, here. So here I have shown the parallelly code. With that code, I'll explain so that it will easy here. Now I'm going to take this array, and the code is also I have given left hand side, if you can see. Now I'm going to explain this. Kindly observe, everyone. So the function remove duplicates from a sorted array. So it is going to take the input array and number of elements. So here the number of elements will be 9. Okay. So here I'm going to take one variable j, and where it is pointing to index number 0. So friends, j is pointing to 0, and I, which is starting from 0 and going till n minus 2, which means if n is equal to 9, it will go 9 minus 2, which means 7, which means till last but one element it will go. What? Variable I. So it's a simple loop variable starting from the 0 and going till last but one element. So what is the code I am checking here? I am comparing, see carefully, array of I and array of I plus 1, friends. So I am simply comparing what is my array of I and array of I plus 1. If they are not equal to, then I am telling do something here. So if they are not equal to do something, I am telling here. But now if you observe, when I is pointing to 0, so I and I plus 1, they are equal, friends. Therefore, this if condition will fail. Then next time I will be incremented. Now I will be comes here. Okay. Now we again compare I and I plus 1. Again, they are equal. So when they are not equal, you no need to do anything. When they are not equal, do something. Now see here. Now compare I and I plus 1. Now clearly they are not equal, right? Therefore, when I and I plus 1 not equal, so if this condition true, what is the first thing that I told? Two steps that I have written here. The first step will be array of j. In place of array of j, I'm saying you to keep array of I. What is array of I? 1. So basically this one I'm trying to keep here. Then what will happen? Then here 1 will come. Anyhow, already there 1 is there, but again I'm modifying it to 1 only. And second step, I'm incrementing the j. So j plus plus, j plus plus. And again, I value will be incremented. Only two steps are there. When array of I and array of I plus 1 not equal, two steps I have written. Now compare again I and I plus 1. So again, they are equal. So when they are equal, you no need to do anything, friends. Now check again. I and I plus 1. Now they are not equal. So when they are not equal, what I told, inside array of j, we need to keep the array of I. That means 2 will becomes here. After that, I'm going to increment the j value. I'm going to increment the j value. So I will remove all this. Now currently j is at index number 2 and my I is at index number 4. So after that, what will happen? I will be incremented. Now compare again I and I plus 1. Now clearly they are not equal. So when they are not equal, in place of array of j, you keep the array of I value. So which means now 3 will come here. After that, j will be incremented and then I will be incremented. Now currently I is at index number 6 and j is at index number 3. Now so far, if you observe, friends, 0 to j minus 1, all the distinct elements came, if you observe, because 1, 2, 3. Okay. Now again, same story, friends. Compare I and I plus 1. I and I plus 1. Again, they are not equal, friends. So you can simply increment your I. Next, I and I plus 1. So again, they are equal. Again, they are equal. If condition will fail, you no need to do anything. Now, when I goes here, my loop will become fail. My loop will become fail. Correct? Everyone agrees on that? Loop is going to fail. Why? Because loop will start from 0 and it is going to run till n minus 2 only. Till index number 7 only it will run. Why I have to run till 7 only? If you run till last element, then to compare I plus 1, there is no element, friends. There is no element. Therefore, always remember, whenever you are comparing I with I plus 1, you have to run last but one element only. Why can't you run till last element? If you run till last element, there is no I plus 1 to compare. Therefore, it will give the undefined error. So it gives the undefined error. Okay. Now, so far we have done and this for loop is completed. So once if this for loop is completed, what is the last step? The last step is array of j is equal to array of n minus 1. Whatever the last element is there, that element I am going to copy here, which means here now element 4 will come. Element 4 will come. So last element, friends. So this step is also completed. So once if this step is also completed, from what index to what index, I am going to get all the distinct elements. I am going to get all the distinct elements from index number 0 to index number j. That is 3, friends. Therefore, I am running another loop I starting from 0 and it is running till j and I am printing all the array elements. Therefore, I will start from 0, 1, 2, 3. Wherever my index number j is pointing, till then my loop will run and output will be all the distinct elements 1, 2, 3, 4. So same is the expected output, right? If this is the input, expected output will be 1, 2, 3, 4. So same output also, right? So is this clear? Is this clear? Okay. Now you might get another question, friends. You might ask, sir, what if last element is not 4, some other element? Some other element. That question you might be getting, right? So somebody is saying, sir, what if this element will be 2? Somebody is asking, what if this element will be 2? If this element has to be 2, then you have to tell me what is the brand you took before coming the class. If this element would have been 2, then you have to tell what is the brand that you took. Is 2 is possible here? First of all, tell me. I clearly told it is a sorted array. If this is a sorted array, how come element 2 will comes here? Tell me. If any element greater than or equal to 4 is possible. Greater than or equal to 4 is possible. Right? Okay. Now, that's why I have taken another example. I know you people will ask a doubt. What if last element is different? So I have taken another example, friends. Now, on the same example, let's dry run this. Let's dry run. So again, this elements also, number of elements will be 9. Now listen carefully, everyone. Listen carefully, everyone. Okay. So again, same story, friends. Initially, J will be pointing here. Now it will be much more clear. Concentrate. So I will be again point here. Now compare I and I plus 1, not equal. Equal. I and I plus 1, equal. So if they are equal, we don't need to do anything. I and I plus 1, not equal. When they are not equal, whatever the array of I, that you have to keep inside the array of J, and you have to increment the J value. Okay. So now I am going to remove. Next, I will be incremented. Now, friends, I will comes here. And now check. Again, I and I plus 1, not equal. When they are not equal, whatever this element, you have to copy here. Whatever the element, you have to copy here. After that, you increment the J value. And again, you increment the I value. Now compare I and I plus 1, not equal. When they are not equal, whatever this element, you have to keep inside the array of J. Then you have to increment the J value, as well as we have to even increment the I value. Now, as of now, 0 to J, all the distinct elements came here, friends. That is 1, 2, 3. Okay. Now again, same story. That is I and I plus 1. If they are equal, you no need to do anything. I and I plus 1 equal. You no need to do anything. Now check. I and I plus 1 not equal. When they are not equal, whatever this element, you can keep here. 4. After that, can you tell me, friends, is my loop is going to run or it will stop? Is my loop is going to run or it is going to stop? Obviously, it will stop, right? Why it will run? Because it will run last but one element only. It will run till last but one element only. So with this loop is over. So once if this loop is over, then last step what I told, inside array of J, you keep the last element. Therefore, last element I am going to keep here. Once if it is completed, then print all the elements from 0 to J. So from 0 to J, what are all the elements are there? 1, 2, 3, 4, 5. So we got all the distinct elements. Right? So I hope, is it clear, friends? Remember? Okay, getting now? Cool. Next question. So crystal clear, very good. So these all the questions which are on the 2-pointer technique, friends. Right? So next we are going to discuss about the sliding window technique. Sliding window technique. Sir, somebody asking why last element we put. अरे अभी तक क्या सुना है तूने? Till now what you have listened? Why we are keeping the last element? We are running till last but one loop. We are running till last but one. Who will take care about last element? For that purpose we are keeping. For that purpose we are keeping. Last element you are not taking care. Who will take care? Our grandfather will come and take care. From heaven. From heaven he will come and take care. Tell me. So if last two elements are same, story will be different. If last two elements are distinct, then story will be different. For that, to be on the safe side, I am running till last but one element only, and this element will be taken care by this way. Right? Cool. So next technique is, friends, so sliding window. Okay, so before any doubts you have having before I move on, any questions here? Last element is 9, same story. If last element is 9 also, same story. Right? Okay, no doubts. Time complexity. Now tell me, friends, what will be the time complexity here? Simple, order of n, because one simple loop you are running starting from 0 to n. So this loop is going to run for order of n time, and this loop anyhow you are printing. We don't know what is the j value. Worst case, this j value came n. Therefore, order of n plus order of n. Overall, it will be n only. What about the space complexity here? What about the space? Here, are we creating any extra array? No, we are not creating any extra array. Whatever the given input array, we are playing. So we are playing on the given input array only. Therefore, space complexity will be order of 1. Space complexity will be order of 1. And time will be order of n. Okay. Sir, confused to take for loop or while loop to solve the questions. We solve with both, but which is good? Anything you can use. I told in my beginning classes, either for loop or while loop, both are having same only. It is up to your convenient. Any loop you can use, no problem. Okay, so there is no restriction that you have to use while loop only here. You have to use only for loop. No, nothing like that. Next concept is, friends. So sliding window technique. One of the important technique, this is sliding window. So again, like how we have seen two models in the 2-pointer technique, even in the sliding window also, we are having two models, friends. Okay. So the first model will be, so sliding window, I will refer as SW, just a short form, sliding window. Okay. So first model number 1. So size of the sliding window will be fixed. So based on two types. So size of sliding window is fixed, or I'll write fixed size sliding window. I'll write model number 1 as fixed size sliding window. SW means sliding window, friends, which means throughout that problem, the size of the window will be fixed. So if the size of the window will be fixed, what does it mean? In the question only they will give. So in the question, they will give the size of the window. In the question only, they will provide size of window. Now let's talk about model number 2. So in model number 2, friends, it is a variable size sliding window. It is variable size sliding window, which means in the question, they won't provide size of that window. In fact, you have to calculate the size. So we have to calculate the size. We have to calculate the size. Okay. So how can I calculate this size? Simple, friends. So let me take one array here. So I'm going to take one array. So some random elements I'm going to take. So indices are 0, 1, 2, 3, 4, 5, 6, 7. So number of elements that are present are 8. Okay, and name is array, ARR. Now, here I told size will be not given. We have to calculate. For example, I'm going to take an array from here to here. So from here to here, I'm going to take one array, friends. Can you tell me what is its size? Size, I mean to say how many elements are there? Can you tell me, friends, here how many elements are there inside this bracket, this box? 4 elements are there. Correct, na? So element index number 2, index number 3, 4, and 5. Now, since this is the window, so every window is having some starting index, some ending index. Now here, what is the starting index of this window? Which is index number 2. Very good. So this is the starting index. Let me call this one as a starting index. What about the ending index? This is the ending index, which is index number 5. Now, this size will be 2. This size will be 4. Sorry, size of this window will be 4. Now, I had a value 2, start will be 2, and I had a value end is equal to 5. Now using 2 comma 5, whatever the operation if you want, you can apply. I have to get a value 4. How can I get it? How can I get it? So you can do 5 plus 2 or 2 plus 5, 5 minus 2. You do whatever you want, but how I will get a value number 4? How I will get a value number 4? So somebody is saying that 5 minus 2 plus 1. So someone is saying 5 minus 2 plus 1. What is this value, friends? 4. Okay. Does it work for every case? We have to verify. So for that, let me going to take some other array, friends. So for example, I'm going to take another array which is starting at 0 and let's say which is ending at 6, which is another array which I have written in the blue color. Now for the blue color one, tell me what is the starting and what is the ending. Blue color. So for this blue color one, I'm writing here, start will be 0 and end will be 6. End will be 6. Okay. Now how many elements are there here, friends, in this? What is this size? 7 elements are there. So size will be 7 elements are there. Okay. Now if I use the same formula, will I get it? Let me check it. That is end minus start plus 1. Yeah, we are getting right. 7. You are getting, friends. Therefore, the formula will be size of the sliding window. If you want to get the size of the sliding window, you require actually 2 pointers. One pointer should supposed to point at beginning of the window and second point which should point to ending of the window. So let me take start and end. Therefore, for formula will be end minus start plus 1. End minus start plus 1. So is this clear, friends? How to find out size of the sliding window? See, sometimes there need not to be start comma end. Maybe you can have I comma j also. So variable names doesn't matter, but the concept will remain the same. See what is the pointer which is at the ending. It can be j also. It can be I also. In such case, what is the formula? J minus I plus 1. Depends upon what is the name that you are using. Need not to be always end comma start. Need not to be always start comma end. It can be I comma j also. It can be low comma high also. Depends. Different. Okay. For example, if I am pointing low here and if I am pointing high here, and if you want to find out its size, same formula, high minus low plus 1. High minus low plus 1. Simple, friends. How many elements are there between low comma high will give its size. Okay, cool. So these are the two different models. So in the first model, size will be given in the question and throughout that problem, that size is going to remain the same. Second model, they won't give the size. In fact, you have to calculate the size. These are the two models. Now we will look into some problems based on two models. So first question that we will see based on the model number 1. But before I explain about model number 1, like how can I identify, yes, this I can solve with the help of sliding window. You have that minimum clarity, friends. Okay, this is the problem they have asked. Now, how should I find out whether I can apply only sliding window only to this question? So there are some tricks are there to apply. There are some tricks are there, friends, where we can apply. So usually these sliding window problems can be applied on either arrays or strings, friends. Either array based questions or string based questions. You can apply. Okay. And to be specific, if the question they are mentioned about either subarray or substrings, and apart from that, in the question, if it is contained something like largest sum or minimum value, minimum or maximum, or longest or smallest. So if these kind of terms can be present in the problem, you can blindly go for the sliding window. Okay. So now one simple example I have given here. First example is, read the question carefully. So given an input array. So एक input array दिया है हमको. So what you have to do, find the maximum sum of all the subarrays of size k. All the subarrays of size k. Okay. So size k given. Now can you tell me, is it fixed size sliding window or variable size sliding window? VW or FW? Fixed size. Why? Because they given, friends. Sizes they have given. So you no need to take any tension. They have given the size K. Size K they have given. Now the question is, given an input array, find the maximum sum of all the subarrays of size K. So let's try to break down the problem. Let's try to break down the problem, friends. Here to here is one part, that is all the subarrays of size K. If size K can be equal to 2, 3, 4, anything. So you have to find out how many subarrays are there of the size K. After finding out all the subarrays, let me take S1, S2, S3, S4. These all are all the 4 subarrays, let's say we got of size K. After finding out all the 4 subarrays, you have to find out sum of the each subarray. What is the subarray of subarray S1 sum, S2 sum, S3 sum, S4 sum? After finding out all those sums, you have to take the maximum of that. That is what the given question says. Among that, you need to find out the what is the maximum sum. So is this question clear? Is this question clear, friends? So what is the maximum sum of all the subarrays of size K? Okay. Now how should we solve this question? So let's come here. So model 1, which is fixed size sliding window. So first question is, now given an input array, find the maximum sum of all the subarrays of size K. Same question I'm extending here. So first, for your easy, they have given one example also, friends. One example also. So one input array they have given, and again this input array need not to be sorted, friends. So one input array 100, 200, 300, 400. So total 4 elements are there, starting from 100, 200, and 300, 400. So total size will be number of elements are 4, and K is equal to 2. Now size of the subarray, that is K, which is equal to 2. So first of all, you need to write what are all the possible subarray of size 2, friends. So size 2, first of all, this is one subarray, which is 100, 200, and second subarray 200, 300, and another subarray 300, 400. Now, apart from this, can you tell me, friends, any other subarray? So which is of size 2? Can you tell me any other subarray? 300, 400, already I have written, na? 300, 400. I'm getting answers. That is another subarray, which is 400, 100. Very good. What is the another subarray? Next, 200, 400. Very good. Very good. Next, come on, tell me. Next, very good. 100, 300. 100, 300. Next. Come on. Any other, apart from this, any other subarrays are you getting? Okay, 100, 400. We have written, na? 400, 100. I hope my previous students are already telling. See, who told you the subarray concepts for you? Who told the concepts of subarray for you? That time they might have told the definition, right? Okay, Bicky told the definition, right? Subarray definition. What he told the subarray definition? In any array, if you want to find out a subarray means, it should be continuous. Then only we are going to call that one as a subarray. Can you tell me, is 200, 400, is it continuous or in between break came? Break came, right? 300. Now, how you can call this one as a subarray? Now, 100 and 300, a break came right here in between 200. So, how you can call it as a 300 is a subarray? Now, 400, 100, it is completely ulta. How can you call this one as a subarray? Huh? How can you call this one as a subarray? So this is not a subarray, friends. It is not a subarray. So subarray means it should be continuous. That's it. And it should be same with this array. Okay, na? So only these 3 subarrays are possible. With size 2. With size 2, only 3 subarrays are possible. That's it. Now, if anybody say other than these 3, can I write another subarray means you simply slap them. If they're asking why you are slapping, again you slap. Next time they won't ask. Next time they won't ask. Okay. So because that's a definition, how can you change the definition? You cannot change it. Right now, friends, these are the only three. Yeah, even in interview also slap them. If they're telling other than any other subarray, if they're getting, slap them again. Okay. So now let's come to the question, friends. Now 100 and 200. What is this sum? This is 300. Okay. Next, what is sum of this subarray? That is 500. What is sum of this subarray? Which is 700. Now, among all these three, we need to return that maximum sum, friends. Therefore, what is the output? What is the maximum output? Which is 700. So, final answer to this question will be 700. 700. Right? So, I hope, is this clear? Is this concept clear? Now, let's solve how to solve this question. We have to understand how we can approach this question. Right? So, this simple example, so there is nothing much to discuss here. So I have taken another example, friends. Now see this example and tell me what is the maximum sum subarray that is there here. What is the sum of it? Its size should be 4, friends. First of all, can you tell me how many subarrays are possible with size 4? Size 4, how many subarrays are possible in the given array of size 9? 6 or 5? Think careful. Think careful. 6 or 9? 6 or 5? Okay. So total my size should be 4, friends. Okay. So 0 to 3, 1 subarray. Now I am noting down all the possible subarrays. First one will be size 4. So 0 to 3 is one possible subarray. 0 to 3. Second, next subarray will be 1 to 4, second subarray. So 1, 2, 3, 4, 4 elements. After that, 2 to 5, another subarray. After that, 3 to 6, another subarray. Then 4 to 7, another subarray. Every subarray size has to be 4 because this is given in the question. This is given in the question. Okay. Next subarray, 5 to 8. 5 to 8. Apart from, can you get any other subarray? Apart from 6 to 9. If you are getting 6 to 9, another subarray means you have to change the brand. Okay, you have to change your brand, right? So because there are no 9th index now, only 8 elements only there, friends. Therefore, only 5 subarrays are there. Okay, now I have to find out sum of all the subarrays. So I am going to take one outer loop, friends, and outer loop basically, listen carefully. Outer loop is starting from index number 0 and till where I should suppose to run? Till index number 5 I have to run, friends. I have to start my outer loop at I, which is index number 0, and I have to run till index number 5. Okay. Why? Because starting from 0, then 1. So I value initially starting at 0, then 1, then 2, then 3, then 4, then 5. So can you tell me, I is 0. You are having n is equal to 9. This value will be 4. How can you get a value 5 from 9, 4? By writing n minus 4. By writing 9 minus 4, I will get 5, right? Therefore, how it will be, friends? I am going to take one simple for loop, I value, which is starting from 0, and I'm going to run till n minus k. Till n minus k means less than or equal to. Correct, na? Less than or equal to n minus k. N minus k. And then I plus plus. I plus plus. Okay. This is done. Now, next, inside that, I have to go till 3. Inside that, I have to go till 3. Correct, na? Therefore, inside, I am going to take another loop for, listen carefully, j value. From where I should suppose to start this? 0 or I? Think careful and tell me. When I is at 0, it is 0. When I next time I changes, na? This is the first subarray, S1. After that, I will changes to index number 1, second subarray. Then it will go to third subarray, S3. Therefore, j I have to start at I. Okay. Now see, friends. When j is starting at I have to run till 3. Therefore, J value, when I is equal to, I is pointing to 0, I should be run till. So when I is pointing at 0, now see this friends, when I is at equal to 0, J value, I have to run till which, what index? Till index number 3. Similarly, when I is pointing at index number 1, when I is pointing at index number 1, can you tell me J value till what index I should suppose to run? Till index number 4 I should suppose to run. Similarly, when I is pointing at index number 2, till which index I should suppose to run my J? Till index number 5. Therefore, now depends upon the I value, my J value changes, friends. Therefore, can you tell me here till what index I have to run or what condition I have to write? It is depending upon I. It is depending upon I. From I, next 3 elements it is running. Therefore, can I write something like I plus 4? I plus, not I plus 4, I plus 3, I plus 3. See friends, here when I is at 0, 0 to 3, 1 plus 4, so 2 plus 3, 5. Okay, maybe you can write 3, but size they have given 4. So it is not 3, friends. It is what? It is nothing but k minus 1. K minus 1. I hope, are you getting? 4 minus 1. Very good. That 4 minus 1 is nothing but a k minus 1. Therefore, J should suppose to run J I plus k minus 1. Less than or equal to, I have written, friends. Less than or equal to, I have written. And then J plus plus. J plus plus. Okay. Now, I am going to compute its sum. Now, here I am going to take one variable, that is sum, which is equal to 0, friends. Okay. Next, if sum is equal to, what I am going to write? Sum plus array of J. Sum plus array of J. It is completed, friends. Okay. First time when I is pointing at index number 0, first time when I is pointing at index number 0, so J is going to start from here and it will run till 3. And what is its sum? 1 plus 4 plus 2 plus 10. 10. What is this value, friends? What is this value? 17. Okay. This value will be 17. So at the end of that, sum is going to get a value 17. Next time, when I comes here, okay, again, J will also comes here. So you have to calculate again 4 plus 2 plus 10 plus 23. Now, what is this sum? What is the next, this sum, friends, which is 39. So from 17 and 39, we have to take the maximum sum, that is 39. Therefore, you require another variable, friends. Another variable outside I am taking, that is final sum. I am going to take another sum. This is final maximum sum I am going to take. Final maximum sum. So friends, whenever if they are talking about maximum, I told you have to start from minus infinity. Am I correct? Whenever you are starting from maximum value, means set it to minus infinity, friends. If they are asking minimum value, you have to set it to positive infinity. Okay. Now, so once if this sum, if I found out this is sum is done, now you just need to compare. For example, whatever the sum that you have computed inside this loop, if this value would have been big compared to existing final sum that is present here. So if this is big compared to final maximum sum, then you have to update this final maximum sum to sum, friends. So for example, we need maximum at the end. Therefore, this one final maximum sum is equal to final maximum sum is equal to sum you have to update. This sum you have to update. So this is completed and this for loop is also end, friends. So finally, where our result will be present? Inside that final maximum sum. Therefore, outside you can simply write print that final maximum sum as the result, or even you can console.log also. So is this clear, friends? Is this clear? So with step by step, I have explained starting from the basic and I derived the formula. And in fact, I have shown the code also. Right. Okay. Now let's try to analyze that. So this code I have already written, friends. So where is that code? Just for your understanding, I have written this code again. See, so for loop, outside for loop, starting from 0 and it is running till where? Till n minus k. Same story. Okay. Next time, inside loop, j value starting from I and it is running till I plus k minus 1. And every time sum I am computing, after computing this sum, if this for loop is over, I am comparing, friends. If whatever the sum that you have computed, if it will be greater than the maximum sum, then update that maximum sum to the given sum. And finally, okay, they are going to return that maximum sum. So I have taken final maximum sum and this is the maximum sum. Right? I hope, is this clear, friends? Is this clear? So if anybody not understand, listen to the video again. Okay, 600 students are present here. So I'm not going to waste their time. Listen the video again if you want. Okay, cool, friends. Now let us analyze the time complexity. So can you tell me, friends, let's understand the time complexity. So how many times roughly this loop will run, friends? Roughly how many times this loop is going to run? Starting from 0, running till n minus k times. Okay, so let me take, this is going to run roughly n minus k times. This loop is going to run how many times, friends? Every time. Whatever the size of that window. Those many times this loop is going to run. That is k value. This is the nested loop. Therefore, you have to multiply. Friends. Correct, no? So n minus k into k. N minus k into k. Now, if I multiply inside, this is n into k minus, this is k into k. Now, n into k will be bigger or k into k will be bigger? Obviously, n into k will be bigger, right? Therefore, its time complexity will be order of n into k. Order of n into k. So is this clear? So k term, let it be, friends. K, let's be here, no problem. Order of n into k. Why k into k now? Why k into k? Arey bro, you go and study some mathematics. In your any 6th or 5th standard students are there, na, ask them, they will tell you. Multiply, man. K you multiply inside, n into k. Then k into k you multiply. So which planet you people are coming here? Okay, cool, friends. Now this is order of n into k. Okay, so friends, let's not ignore the k value. Let it be, no problem. Order of n into k. Now here, if you observe carefully, we have to understand what is the problem in this code. Actually, there is no problem in this code, but unnecessary calculations we are computing here. If you observe carefully, first one is I am computing the sum from 0 to 3. That is 1 plus 4 plus 2 plus 10 I have computed. When I is pointing at 0, from there, first 4 elements. Again, when I comes here, you are computing again, this is 4 plus 2 plus 10 plus 23. Again, when I comes to index number 2, from here, what is the next 4 elements you are computing? That is 2 plus 10 plus 23 plus 3. Again, afterwards, next time 10 plus 23 plus 3 plus 1. Like that, remaining all the subarrays you are computing. Cool. Now, if you see here, first time you are already computing from 1 to 10. So 4 plus 2 plus 10, you are already computing when I is at 0. Now see, friends, again you are computing 4 plus 2 plus 10 and then 23. What is the difference from here and here? Recomputation you are trying to do. Now same sum, when I is equal to 1, you have done. Now even if you see 2 plus 10 plus 23, which you are already computed here, but again you are doing recomputing. Don't you think these all are unnecessary recomputations? Tell me, friends. Don't you think these are unnecessary recomputations? So what I am going to do is, First of all, independently, I am going to find out the first 4 elements sum or whatever the k value. First k values sum I am going to compute. After computing first k values sum, so let me take this one as a sum. Now, if you want to get this sum, what I'm going to do from this sum, I am going to remove the first element, that is 1, and I am going to add the 23. Don't tell me, can I get the same value or not? From the above sum, if I remove the element number 1 and if I add the 23, I am going to get the same sum. Now again, from this sum I am going to take, from there I am going to remove minus 4 and I am going to add the 3. Tell me, don't you get same sum? From this sum, remove 4, add the 3. So 2 plus 10 plus 23 will be same and extra 3 is getting added. Similarly, I am going to do the same process. Okay, by doing this process, let us see how we can save the time complexity. Okay, so here I have shown the code, friends. So by showing the code, I will explain this concept. This is 1 minute. So same array I'm going to take. On the left hand side, you can see the code. Now this is the given input array. So the function, so clearly this is a fixed size because k value they have given, input array and the number of elements and what is the size of the given array. All the 3 parameters will be given in the question. So first here what I have taken one variable, that is maximum sum. So maximum sum is a one variable, and inside that maximum sum, what I'm going to do here. So first I'm going to take the first loop and initially its value 0 I'm setting. So in the first loop, starting from 0 till k minus 1, if k is equal to 4 means starting from 0 till 3, I'm going to find out sum of all the first 4 elements, which is 0 to 3, this loop, friends. Then what is the value that I'm going to get inside that maximum sum? 1 plus 4 plus 2 plus 10. And what is this value? This value will be, I think, 17. So this value will be 17, friends. After that, this loop is over, friends. This loop is over. Now I am coming here, next code, continuation to that code. I am going to take another variable, that is current sum. I am going to take one variable current sum. Okay. Inside that, I am storing the maximum sum, that is 17. I am storing that value 17 and I am continuing this loop starting from I is equal to k onwards. What is k? Index number 4. So I am starting my I value from index number 4. Why only you are starting from index number 4? Why? Because first 4 elements is already taken care by this loop. This loop had already computed the first 4 elements sum. Therefore, I am starting my loop I from index number k, which is from 4, friends. Until where I am running? Till the last element I am running. Okay. Here, what is the first line that is saying that current sum is equal to current sum minus. What is the current sum? Which is nothing but a 17. And what is meaning of 17? 17 is nothing but 1 plus 4 plus 2 plus 10. First window sum that I have computed, friends, which is 1 plus 4 plus 2 plus 10. Next, what I am expecting? I am expecting this sum, that is second array. 4 plus 2 plus 10 plus 23 sum I am expecting actually. And you have already 1 plus 4 plus 2 plus 10. And my I is pointing at here. Now, second sum, that is, if I want to get 4 plus 2 plus 10 plus 23, already you are having 1 plus 4 plus 2 plus 10. From there, I am going to remove this value and I am going to add this value. Therefore, current sum is equal to current sum minus array of I minus k. When I is at index number 4, okay, k is at value will be 4. What is I minus k? I minus k will be 0. So whatever the value that is present at I minus k, which is 0, I am going to remove, that is minus 1 plus I am adding array of I. What is array of I? Which is 23. which is 23, friends. Then this 1 and 1 is going to get calculated, and it is going to remain 4 plus 2 plus 10 plus 23. This is the new value which is present inside this current sum, friends. Now, what is this value? Tell me, friends, what is this value? 39, right? Okay, so this value will be 39 inside that current sum. And once it is done, second step, what I have written, maximum sum is equal to maximum of current sum, comma, maximum sum. Currently, what is the value of current sum? That is 39. What is maximum sum? This is 17. So among these two, whichever is maximum, that will be present inside that maximum sum. So which is nothing but 39. 39, friends. Once it is done, again I value will be incremented. So I value now comes to index number 5. Index number 5. So when I comes to index number 5, first subarray is completed, second subarray is also computed. And what is the second subarray sum that you got? 4 plus 2 plus 10 plus 23, which is happily present inside that current sum. Then you have to find out the third subarray, that is 2 plus 10 plus 23 plus 3. This is subarray sum you want to compute, friends. Since you want to compute this subarray sum, which is 2 plus 10 plus 23 plus 3, from the available current sum, that is 4 plus 2 plus 10 plus 23, you should suppose to remove this value. You should suppose to remove this value, and you should suppose to add this value. Add this value. So how can I get that minus 4? I minus k. What is I? 5. What is k? 4. 5 minus 4, 1. Yes, we are going to remove this. Plus array of I. We are going to add this. Then 4 and 4 is going to get cancelled. And it will be 2 plus 10 plus 23 plus 3. Therefore, can you tell me what is this value? What is this value? What is this value? 39, 38. Okay. So this value will be 38. But is it already better compared to existing 39? No, right? Therefore, it will not get updated, friends. Current sum, maximum sum will not get updated. And the next time, now my I will goes. So like that, can you able to run the remaining things? Can you able to run, friends? So similarly, okay, remaining things, it will same happen. Finally, you know, what is the value that is present inside that maximum sum? You are going to get the final output. Final output. Okay. Now, so now I am going to compare these two things, friends. First approach, second approach. So in the first approach, what is the time complexity, which we have already verified? That is order of n into k. Order of n into k. First approach. Okay. Now in the second approach, let us analyze its time complexity. Now, what is the time complexity of this code? How many times this is running? K times. This code is running roughly k times. Now, how many times this code is running? How many times this code is running? Starting from k and running till n. Therefore, it is running n minus k times. N minus k times, friends. Therefore, you have to add both of these two. If I add both of these, k plus n minus k. K will get cancelled. This is going to run. Or when you are trying to add two parameters, first one will be k and second one will be n minus k. N minus k. So which is k will get cancelled. It will be n. This, what is the time complexity? Order of n into k. But what is the time complexity of this approach? Order of n. So if you compare this approach without sliding window, this is without sliding window. This is with the sliding window. With the sliding window. Now, how much amount of the time we are able to reduce? By k times. K times we have reduced its time complexity. So k times we have reduced the time complexity. So is this clear, friends? What is the advantage? Super clear. Very good. What is the time complexity of math.maximum? That is order of 1. These are the inbuilt order of 1 time, friends. Simple if else you can approach. Simple if else approach, which is order of 1. Its time complexity. Sir, how to click? We have to reduce such code by practicing some problems. You will get it. By practicing some problems, you will get it. Okay. Yeah. So now you can take a break. We will meet at 10:40. 10:40. Yeah. We'll meet at 10:40. Okay. So friends, next question we'll discuss on the variable size sliding window. That is method 2. One question here. So the problem statement is, now see the problem statement. Find, is there any subarray? Find, is there any subarray with the given sum? So usually here, one array will be given, friends. Number of elements will be given and some value will be given, which is 33. Now you need to find out, is there any subarray? If yes, you have to return true. Otherwise, you have to return that false. Now see in this array, any subarray is there whose is 33, whose value will be? Is there any subarray? If yes, can you tell me what is the starting and ending index? What is the starting and ending index? Yeah, somebody is saying 2 to 4. 2 to 4. So let me take a subarray from 2 to 4 and I'll find out what is sum of this subarray. What is the sum? 20 plus 3 plus 10. Yeah, so 23 plus 10, 33. Yes, we are having one subarray, friends, whose value will be 33. Therefore, you can return true. So sometimes you might get more than one subarray also. Sometimes you might get more than one subarray. So if yes, you can return true. Okay. So first, what will be the brute force approach? Simple brute force approach. So try to generate all the possible subarrays using nested loop. To generate all the possible subarrays, you require 2 loops, order of n square. After finding out all the subarrays, you have to compute sum of the each and every subarray, right? So to check sum of the each and every subarray, that size will be n. So overall, its time complexity will be order of n cube. Correct now? But maybe can you do it in less than n cube? Can you do it in less than n cube? So there actually the sliding window concept comes into picture. So we have to take the windows one by one. In the next slide, I'm going to explain. See here, left hand side, I provided the pseudocode. Now by this pseudocode, I'll explain this concept. Yeah. Now see, friends, this is the given array and number of elements will be 6. And what is the sum? Sum will be 33. Okay. Is it variable size or fixed window? Here window is size is not given, friends. They didn't told any size. Array size can be 1. For example, here instead of 1, if I'm having 33. Yes, I found out a subarray whose size will be 1. Therefore, I can return 2. And I had another subarray whose size will be 3. Therefore, there is no fixed size here. Sometimes array size can be 1 only. Sometimes 0 cannot be exist also. In that case, the array size is going to be 0. Correct. So clearly it comes under variable size sliding window. So when it is variable size sliding window, you should supposed to know what is the starting index and what is the ending index. Or sometimes they can call it will be low, it will be high. Depends on the whoever writes the code, friends. So these variable names doesn't matter actually. Now see the code on the left hand side, which I have written. So I have taken 2 variables. One is window sum and the second variable will be high. So window sum, I'm going to write WS, which is window sum. Initially, its value will be 0. And it is pointing, high is a variable, which is pointing at index number 0. High is pointing at index number 0. Now I have taken one loop here, one for loop, which is starting at index number 0. And it is going till last element. So a variable low starting from index number 0 and going till last element, friends. After coming inside that while loop, now inside that for loop, I have written another while loop. So this is a combination of for loop and while loop. Now let's see what this while loop is trying to do. So what this while loop is trying to do? First condition is my window sum is less than sum. I'm going to check. This sum will be given 33. initially what is the window sum, which is 0. As long as if my window sum is less than 33, I will keep on add that array of high, this element to the window sum. First time I am going to add this value 1, and then I am going to increment the variable high. So I am going to increment the high. So I have written high plus plus. Again, I am going to check, friends. Whatever the 4 value, I am going to add. So this is going to become 1 plus 4, which will be 5. And again, high value will be incremented. See, remember, we need a subarray. Subarray means continuous. We need a subarray. Meaning of subarray is continuous. So it should be continuous. That's why continuously I am finding the sum. 1 plus 4, 5. And then I am going to check. 5 is anyhow less than 33. Therefore, I will add this 20 also to here. Then which is going to become 25. After that, high I am going to increment. So high will be incremented. Then all came here. So now after incrementing high, I am going to compare. Is my 25 is less than 33? Yes. Then I will try to add this 3 also to this 25. Then it is going to become 28. So this, what is meaning of 28, friends? 1 plus 4 plus 20 plus 3. That is the meaning of 28. So once if I added, I am going to increment my high value also. So high value also I am incremented. So once after incrementing the high value, I am going to compare again. Is my window sum is less than the given sum? Yes. Then I am going to add this value. Then which is going to become 38. Okay. So it is going to become 38. And then high value, I am going to increment. High plus plus. After adding, you are incrementing the high value, friends. After adding the high value to this, I have incremented it. Now my low is pointing here. Now I am comparing. Is my window sum? As of now, what is the window that is there? Starting from 0 to 4. This is the window. Currently, we are having that sum. 0, 1 plus 4 plus 20 plus 3 plus 10. And that sum will be 38. Now I am going to compare. Is my window sum, is it less than the given sum? No. I'm going beyond than required. I required a sum of 33, but I'm going beyond than required. Then this while loop is going to fail. This while loop will fail, friends. Why this while loop will fail? Because you are getting the sum which is required than extra. Okay. Now I am coming here. Now I'll simply compare, friends. Is my window sum and is my sum both are equal? If they are equal, we are happy because we are getting the required sum. We are getting the required sum. But this is not equal. Na? This is 38 and this is 33. Therefore, now I have to remove some of the elements from 38. So basically 38 is nothing but what? 1 plus 4 plus 20 plus 3 plus 10, which is continuous, friends. Now, in this subarray sum, if I want to remove some element, can I remove element 20 from this? I need a subarray. I need a subarray. Can I remove 3 from this sum? Can I remove 10 from this? No, you cannot remove. Can I remove 1? Yes, I can remove 1. Why? If you would have been remove this 20, then array is breaking. We want a subarray. Since you want a subarray, therefore you cannot remove whatever the element which you want. You can remove only the left-hand side element only. Leftmost element only you can able to remove. Therefore, I am going to remove this element, friends. This element I am going to remove. Okay, somebody is saying I can even remove 10 also. Are if you remove 10, what is the use? Okay, you will remove 10. Again, you have to add 5, but is it continuous? No, na? No, right? So we are cutting from the left hand side, one by one element, we are cutting and we are coming to right hand side. Listen, at the end, you will get a clarity. At the end, you will get a clarity. Therefore, what I am doing, if my window sum is not equal to sum, then from the existing window sum, I am going to remove array of low, friends. Array of low, I am going to remove. Then what will happen? What is array of low? This element. If I remove that element, then the new window sum is going to become 4 plus 20 plus 3 plus 10. So initially, what is the window sum? From 0 to 4. Initially window. First time our window will be 0 to 4. 0 to 4. Now, I thought that by adding this element, I am going beyond than the required sum. Therefore, I am removing this element. So if I remove this element, then my new window is going to, its size is going to get reduced, friends. So low comes here. After low plus plus, I have written. Now I am checking again. Is my window sum, is it less than my sum? Now currently tell me what is this window sum? 4 plus 24, 37. 37. Now check. Is my 37, is it less than the given sum? No, I am again going beyond than required. Therefore, this while loop is going to fail. And I am going to compare, is my window sum and they both are equal? If yes, I am happy. But they are not equal. Therefore, from the window sum, now I cannot remove whatever the element that I want. You can remove only the element number 4. You can remove only this element only, because we need a subarray. It should be continuous. Therefore, if I remove 4 from this, then I am left with 20 plus 3 plus 10. 3 plus 10. And my low comes here. Okay, now can you help me? What is the new window sum? Which is 33. Which is 33. Now, after incrementing my low, I am coming again here. Is my window sum is less than the given sum? No, 33 is not less than 33. Therefore, this while loop will fail. Now I am coming. Now I am going to check. Is my window sum and the given sum both are equal? Yes, equal. Therefore, we are happy. And you can simply return true, which means program is completed. It will return true, friends. Otherwise, again, we have to remove this 20 from this array. We have to remove. So I hope, are you getting right how it is working? Initially, our window size is 0 to 4. Now the new window size will be 1 to 4. Still, we thought that this is not useful. Then next time we have reduced the window size. Why only I am reducing 1 by 1? Because we need a subarray. It should be continuous. That is the reason I am not deleting whatever the element that I want. I am doing it in a proper way, friends. Proper way. That's why. So finally, I got a required array whose size will be, whose sum will be given sum. Okay. Now let us analyze the time complexity of this program. Let's analyze the time complexity. Now, inside for loop, another while loop is there. It doesn't mean that it's a time complexity order of n square. I told yesterday class, we have to analyze it. We have to analyze it. Okay. Now, worst case, can you tell me times? Friends, this loop is going to run for n times. That we already know. Now, but for every iteration of low is equal to 0, is my loop is going to run n times? For every iteration of low? No, it won't going to run. Initially, if your low is pointing at here and high is pointing at here, okay, so high can come, high can come, high can come here, high can come here, high can come here. By the time if you are exceed, then this while loop is going to get failed. Next time when low can be incremented, then this while loop will never be incremented. Why? Because this condition high is by the time high came here. Therefore, from low is equal to index number 1 onwards, this loop will never get executed. All are these are the constant time operation. These are all constant time operation. Okay. Getting enough, friends. That's why only overall time complexity of this program will be order of n only. Overall time complexity will be order of n only. So inside one loop, another loop is there. It doesn't mean that it's a time complexity n square. So you should be careful about, friends. You might ask a question, why I have written high is less than n? You might get a doubt. You might get a doubt that why I have written high is less than n. Why? Because array inside you are incrementing the high plus plus. Therefore, you should be careful about your high value. Na? If high is crossing the array boundary, then when you are adding array of high, don't you think it will give undefined? Undefined. Therefore, you should be careful. Therefore, you should be careful about that value, friends. You should not allow your high variable to cross the boundary. So overall, this time complexity will be order of n when we use the sliding window technique. If you are not using sliding window, you will end up with the n cube time complexity. N cube time complexity. So I hope you understood, friends, these two. What is fixed window? One problem I told. Variable size, second one problem I told. Now I'm going to give some questions for your practice, and you can practice all those questions. And in the next class, we are having a one PSC on that context. Okay, so that's it, friends, for today's class. And Navid want to take some topic, actually not a topic, some concept interview explaining something he want to take. So I'll hand it over the session to Naved. Just give me a minute. Please everyone stay. Please everyone stay. Okay. So where is Naved? Are you there? Arey, where is this fellow? अरे कहाँ चला गया इन्होंने? Just a minute, friends. Let me pause the video till then. He asked that he want to take one. Yeah. So Navid, you can start. I will make you host.